If you were at the keynote sessions this morning, you heard Fernando and Peter talk about sustainability for Project Jupyter in general. And so, Peter mentioned that he didn't coordinate with Fernando, and clearly we didn't coordinate with either of them. But really, you could view our talk as sort of a deeper dive into one aspect of sustainability for Project Jupyter, which is sort of more active engagement between the open source community and industry partners such as Bloomberg. And we hope that by sharing our experience at Bloomberg, hopefully this will shed some light onto sort of successful collaboration models going forward for the open source community and other partners. So to get things started, so my name is Cheryl, and I'm a developer, and this is my colleague Srinivas. He also goes by Sri. And Sri is a quantitative finance researcher at Bloomberg, and so he spends his time between developing quantitative models to explain the trends in the financial markets, and also contributing to BQplot, which is an open source charting library that he's going to be telling you a lot more about later. So we wanted to take the opportunity today to introduce how Jupyter Notebooks came to be adopted at Bloomberg. It'll come as a surprise to nobody here that Jupyter Notebooks feature very heavily in Sri's day-to-day workflow as a quant at Bloomberg. And really, it was actually the needs of the quant research team at Bloomberg that led to sort of this idea of starting to participate more actively and collaborate with the open source community. And so we wanted to tell you a bit about that story and also give you an overview of two of the projects that resulted from that collaboration, primarily contributions to the Jupyter Widget ecosystem, as well as collaborating on the next generation frontend for Jupyter, Jupyter Lab, which you might have already heard a lot about today. So we'll give you an overview of those projects, and also, one second, we wanted to share some, like I was saying earlier, we wanted to share some reflections on our experience. So hopefully, perhaps if you're coming from a company today and you're thinking about possibly collaborating more actively with the community, hopefully we'll be able to have some insights for you today on that. So before we get started, could we have a quick show of hands? How many of you here have contributed to any open source project? Oh, that's a lot of the audience. That's great. How many of you have contributed to Project Jupyter? OK. How many of you here are industry representatives? A few. OK, that's good to know. So let's get the ball rolling. So this is a snapshot of what a subset of the Jupyter ecosystem looks like today. And as a major disclaimer, this is by no means a comprehensive image. I see some people taking photos of it. Disclaimer, this is not the textbook image for it. There are definitely pieces missing from this. But what we wanted to convey was that there are many more aspects, many more components in the ecosystem today than there were even just a few years back. And it may not be that widely known, but actually quite a number of the components here actually arose or have grown from the result of sponsorship and collaboration with multiple industry partners. So just for a few examples, if you were at the front ends talk earlier this morning, Interact actually received funding from companies such as Plotly or Domino Data Lab in its early history, and today Interact also enjoys developer contributions from companies such as Netflix. A couple other examples, you have Qt Console, which enjoyed some funding from Enthought in its early days, and you also have Jupyter Dashboards. I think we missed that out here, but Jupyter Dashboards were a result of collaboration between the community and IBM, and Rackspace continues to provide hosting for NBViewer. So that's just a sample, of some of the collaborations that have gone on in the past few years. So where does Bloomberg fit into this picture? And what is our history with Project Jupyter? So as you can see, we fit in right around the widget ecosystem and Jupyter Labs, as I was alluding to earlier. For some context of who we are as Bloomberg, well, we're a software firm that provides data, software analytics to financial professionals, and we have about close to 5,000 engineers working at Bloomberg. So over the course of many years, Bloomberg has actually invested a lot of time and effort developing interactive proprietary charting libraries specialized for financial professionals. So a couple of examples of this might be something known as an open high low close chart, which shows price movements for financial instruments. And we also have things like interactive supply chain visualizations. Now, if we take ourselves back a couple of years, let's put ourselves back in 2013. So Sylvain Collet, where's Sylvain? Is he here today? Oh, hi. From our quant research team at that time. He made the pitch that we should be adopting Jupyter Notebooks more widely at Bloomberg. And the pitch was that with the notebooks, we'd be able to share code and results more easily, as I'm sure everybody here is intimately familiar with, and that also in the long run, we'd be able to build complex interactive applications more easily. Unfortunately, at that point in time, the Jupyter widgets infrastructure was in an experimental alpha state. And the thing is, so as I was saying earlier, most other Bloomberg applications already were being built with very rich interactive proprietary charting libraries. So in order to adopt Jupyter Notebooks, it was really essential that the users of Jupyter Notebooks also have access to really powerful visualization libraries. But the widgets infrastructure was in alpha state at the time, so what was the only option? Well, the option really was if we wanted to adopt notebooks and make this a success at Bloomberg, we should have to contribute back to the community and say, let's take the widgets infrastructure from alpha state to production readiness. And so that's exactly what Sylvain and the rest of his team did. And so Sri is going to tell us a little bit more about what the Jupyter widget infrastructure comprises, and he's also going to delve into the details of BQplot, which I was mentioning earlier is a charting library that they also contributed to the widgets ecosystem.
Thank you, Cheryl. Good evening, everyone. So I'll start off by listing some of my team members and Paul here, who's the only one looking in the other direction. And so these are the main contributors to the widget infrastructure of Jupyter. So just to take a step back, so what are widgets? So just as a show of hands, how many of you are familiar with and have used widgets in the notebook? Okay, so that's a good amount, like about 60%. That's good. So I can go a bit faster through this. So for those of you who are not familiar with it, so a widget is a Python object which has a representation in the browser. So basically, you can interact with the browser representation of the object, and it changes properties of the Python object. And with that, you can invoke custom Python code to be triggered when the user interacts with the visual representation. So how is this done? So this is enabled by bidirectional communication between the Python kernel and the front end. So what happens when we create a widget is that a corresponding widget model is created on the JavaScript side. And whenever we display the widget, a widget view is created. And when the user interacts with the widget view, the widget model sends a message to the Python side saying that this attribute has changed or this action has taken place. And then we can trigger custom Python functions based on the message that we got back. So next, so you might be thinking, okay, that sounds cool, but what do I have to do with it? So then, everyone can use the widget infrastructure to build interactive applications easily using only Python. So all the JavaScript part is taken care of for you. So you can use the Python components to build interactive applications. And from a researcher or a data scientist point of view, it enhances your research workflow. So if you look at the GIF to the right of the screen, So this is what is a Lorentz system of differential equations. So if you don't know about it, trust me, I also don't know about it. I just picked it up from Brian Granger's talk. So for every set of inputs, this is the three-dimensional surface that it outputs. And we can understand how it evolves when we change different inputs by just operating with the sliders. So this enables you to understand what your function is doing in this case, and also to ask the right questions as a data scientist. Rather than manually going through and trying to figure out what is happening, this enables you to do it in a very intuitive way, and you can arrive at your results faster. And one more thing you can do with interactive widgets is, you can embed interactive widgets in your HTML web page. So basically, if you've built something, built a dashboard, as was demonstrated by the talk by Roma and Chakri in the morning. So if you haven't checked out the talk, I strongly recommend you to. So you can build an interactive dashboard and then have it embedded in a web page. And you can also connect to a remote Python kernel, and so you can have custom Python code executing somewhere, and then the results are displayed for you on a web page. And all of this is easy to do. So taking a step back, so the widget framework is actually a communication protocol between the JavaScript and the Python side. So there can be a lot of implementations on top of this communication protocol. So one of that is BQplot, which is a 2D plotting library, which I'll go into next. So I'll just go to the next slide. Yeah. So yeah, BQplot is a 2D plotting library, which was developed by my team, which is the quant research team at Bloomberg, because at that time we felt that there was no Python charting library which could provide us with the kind of interactivity which will be very powerful and useful for us in our daily work. I know what you're thinking. OK, great. One more Python library, one more API to learn. So don't be disheartened by that. So to ease your pain a little bit, BQplot uses an imperative Python syntax, which is very similar to Matplotlib's PyPlot. So with very little effort, you can use BQplot and gain the interactivity that is provided by it. So the good part about BQplot is that every element, every attribute of the chart is also a widget, and this can be bound to a Python function. So whenever that attribute is changed, either from the JavaScript side or from the Python side, so you can invoke custom Python functions. And we also have a lot of tools and high-level abstractions to enhance the workflows of data scientists and quants. For example, I'll show in the demo soon, which is a hand draw. So it is something which will enable you to draw your own custom scenario and see, say, how that impacts your portfolio performance. Or so for all the data science, for all the neural network enthusiasts, which is pretty much everyone these days. So we have a directed graph, and we also have tools for analyzing your neural networks and understand what to modify and how to do it. So next, I'll go into a small demo. So this is the famous Wealth of Nations example by Hans Rosling. So in this, each bubble corresponds to a country, and the size of the bubble corresponds to the population. On the X, we have the income, and on the Y, we have the life expectancy. So in an ideal world, we want all the countries to go up to the top right corner. And if you see as we play the video, we are slowly getting there, so that's a positive sign. In addition to the very famous visualization, we added our own twist to it, which is when you hover on a particular country, you see the evolution of that country in this 2D space over time. So basically, you can get an idea of how the country's GDP and life expectancy evolved. And you can also see that World War II was not a very good time for most of the countries with respect to life expectancy. Yeah. And the best part about this is that this requires only 16 lines of plotting code on the Python side, and only Python code. So to give another small example, this is a visualization of the county results for the 2016 presidential election. So that was all the code which was required to generate this. And basically, you have a nice interactive application where you can hover on each county and see what is the percentage, how the county voted in this election. So to just go into a bit of detail, so how is BQplot implemented? So on the Python side, we are based on the IPyWidgets infrastructure. And so this can be used to create full-fledged web applications using only Python code. On the JavaScript side, we are built on top of D3.js. So we have all the nice, cool interactivity from D3. And we also use many of the D3 abstractions like scales, axes, etc. And our object model is based on grammar of graphics. So grammar of graphics is a paradigm which tells you how to compose your visualization using different basic components. And if you're aware, the very famous R plotting library, ggplot, is also based on this. And just to emphasize one more, so the data and code is entirely on the Python side. So you don't need to write any JavaScript. So now I'll go to a couple of demos. So this morning when I was talking to, how many of you have seen the movie Fight Club here, just as a show of hands? Yeah, a good number. So in that, Tyler Durden says that the first rule of Fight Club is to not talk about Fight Club. And my friend was saying that the first rule of a live demo is to not do a live demo. But let's see how this goes. So, OK, so here I'll first show you an example of a widget that I mentioned before, which is called the hand draw, in which you can, I'll briefly explain what this is. So here, the chart at the top is the price series of an asset. And in the bottom, we have constructed, so you can consider the magenta and the green lines as two strategies trading on this asset. And these are the P&Ls of that strategy. So now if you want to see how the strategy performs in different situations, so what we can do is we can draw the scenario. Sorry, one second. Yeah, here you can see that I can draw the scenario that I want, and I can see basically how my two strategies would have performed in those scenarios and what my P&L is. So this is useful for like inputting your own custom scenario and seeing how that impacts like different things of interest for you. So in the second part of the demo, I'll go into, so this is part of a project that we did in a 24-hour hackathon, like me, Silva, and the other Jupyter widget contributors that I've shown you before. So this was so we had a lot of data regarding different attributes of different neighborhoods in San Francisco. And what we were trying to do is trying to understand, so what attributes are driving so we also have survey data regarding the happiness, whatever that means, of people in different neighborhoods. And then we were trying to see how, what attributes are contributing to the happiness of the people in the different neighborhoods. So here we are using a library called IPyLeaflet. So this is just a plot of just a map of San Francisco here. Now, what we do next is we want to overlay it with the satisfaction score, which is the survey data. So basically, the darker the green, the more satisfied the people are. So you can see that people who live around here and people around here are more satisfied than people in other areas. So next, we wanted to see like how are the different attributes varying across the different neighborhoods. So this can be used by, say, the city administration to identify which where they should spend their money. So if in a neighborhood they want to improve the well-being of the people, what should they concentrate on? So for that, basically, okay, I'll just go into the code here a bit so that you understand that this is easy to do and you also understand how to do it. So first I have a drop-down. So this is from IPyWidgets.dropdown. And I'm looking at all the columns of the data. And then my default value is one labor participation rate, which is arbitrary. And so here, if we look at it, so what we are saying is on the dropdown, we are observing whenever the value of the dropdown changes, call the function update dropdown. So what does update dropdown do? So update dropdown takes in the data for the new value of the dropdown, and then basically sets the different elements of the map with that color, and then renders the layer. So what do we get out of that is basically the map, and then we have a drop down for the different attributes that we have. So if you want to look at how transportation cost varies, so once we select transportation cost here, we see that for these neighborhoods, the transportation cost is less compared to other neighborhoods. So just a disclaimer, I've been to San Francisco only twice, and I assume there'll be less people from San Francisco here because we're in New York. So if you find any inconsistencies in the data, please, yeah, that is just a minor oversight. So you can basically look at different attributes and see how they are varying for different areas of San Francisco. So next, what we wanted to do was basically look at the satisfaction index and see how that varies across, and see what attributes are contributing to the satisfaction index. So here, what we have is the map again, overlaid with the satisfaction index, but now we've tried to link it to the chart. So when we hover on a particular neighborhood, so just to explain this chart on the right here, so one is the mean of that feature across all neighborhoods, and the other ones are just giving you ratios. So a higher value means that that particular attribute is higher compared to the mean value, and so on. So when you hover over a particular neighborhood, it shows you like how that neighborhood is doing on the different features compared to everything else. So yeah, then you can get a better understanding of like what neighborhood is better for what characteristics. So next, we have a very simple model in which we try to find out which features are contributing most to the satisfaction index. So here we just use a very simple random forest model from scikit-learn. And what we have is something which shouldn't surprise you at all, which is that housing cost is one of the most important determinants of people's happiness in San Francisco, which I would assume is also true for New York. So yeah, next I'll go to the third part of the demo. So since we've established that housing cost is the most important determinant of human happiness, we'll look at housing costs for Boston. So this is the data set is basically Boston house prices. So it gives you the house price, and you get to analyze it against different features like the crime rate, and so 1 second, it should be up soon. You have the crime rate, then you have the nitric oxide content, the average rooms in the house, then the distance to employment, etc. And now we want to understand like what is the dependence of the house price on these features. So for that, so using the widget framework and relying on scikit-learn, so we built a small widget in which you can basically explore different models and try to see what factors are determining the house price. So so the default model to start here would be a linear regression. Okay, I am typing it wrong. Linear regression, yeah. So once you've selected that, so you have all the attributes for the linear regression here, and because of scikit-learn's very nice API of fit and predict, you can easily substitute one model for another and see how it performs. So once we fit a linear regression, we see the results of the linear regression here. So here what we have is the predicted house price on the Y and the original house price on the X. And basically, we can see that over these points, in these points over here, it's doing bad. So to quickly analyze it, you can basically hover over the point. And this is a radar chart, which is also another higher level abstraction in BQplot. So here you can see that the average rooms is higher for all of these points where the model is under predicting. So maybe one thing you can do is, to increase the importance of average rooms. Or if you've heard that random forest works well, you can just try that without having to know too much about it. So you can edit all the parameters here, and then do the same fit and predict. And once you do that, so you do see that the linear regression had a 66% R-square. The random forest does much better, but still it is lacking in this. But this can basically guide your model development process and help you with arriving at the optimal model faster. So 1 second, yeah. Now that we've done this. Yeah, so the widget ecosystem, as I've shown, is not just one library, but there are multiple libraries built on the same framework. So we have bqplot, IPyLeaflet, which we've talked about, and then we have Py3JS and IPyVolume, which are 3D plotting libraries. There are some very interesting libraries here, like IPyAladdin, which is for interactive sky visualization. So maybe we could have all sat here and watched the eclipse without going anywhere. And so at this point of time, I'll hand it over to Cheryl to talk about Jupyter Lab and also the reflections and the learning that we've gained from our collaboration with Project Jupyter.
Thanks, Sri. So hopefully that whetted your appetite for looking at more tutorials or presentations on the widget ecosystem if you haven't already seen lots of them before. So as we were saying earlier, really, the widget infrastructure and as a result, sort of the libraries that have been built on top of that really came about because at Bloomberg we needed to we wanted to adopt notebooks widely within the company, and we needed access to this rich interactive visualization that wasn't fully ready or available at that time. And so many developers at Bloomberg started contributing to the open source project as a result. And sort of if we go back to that point in time a few years ago, another thing that was really important was, well, if we are going to be adopting these notebooks widely within the company and we're going to be supporting somebody like Sri who uses these workbooks heavily day in and day out, well, at some point, maybe they might need a more sophisticated development environment. We want to make sure that Sri doesn't ever get frustrated with the kinds of tools that are available for him to use. And so as a result of that thinking, that was also partly what contributed to another collaborative initiative between Bloomberg and the Jupyter community and Continuum Analytics, which is the Jupyter Lab next generation Jupyter front end. How many of you here today watched the Jupyter Lab presentation earlier by Jason? Most of you. So that's great. So we're going to go just really quickly over this, just for the benefit of anybody who wasn't there earlier. So Jupyter Lab really was designed as, expressly designed as a highly extensible plugin-based framework, because the thinking was, we want to provide a sophisticated IDE around the classic notebook, but also there may be many features down the line which we don't know about yet, which employees like Sri might ask us for in 2 years, and we would want to be able to easily customize and adapt the front end in order to easily add on those features. So if you use Jupyter Lab out of the box, some of the plugins that you might get might be things like the file browser or terminal or console windows or a CSV viewer plugin, for instance. And as you can see on this screenshot, you can also drag and drop the windows and create very customizable layouts in Jupyter Lab. And this is because of the Phosphor.js libraries that it's built on top of that were built in parallel with Jupyter Lab that gives you the ability to really recreate a desktop application-like experience, but on the, in the browser instead of on the desktop. So that's really just a few sentence summary on Jupyter Lab. Definitely check out the other talks if you want to know more about it. And really, what we wanted to share was sort of this collaboration experience and some of our reflections on it. So as we were saying earlier, there were multiple developers at Bloomberg who were contributing to the widgets ecosystem. And in the case of Jupyter Lab, we were very fortunate because, as you can imagine, this is a very major undertaking for anybody. And with the backing of the CTO office at Bloomberg, We were able to sponsor multiple developers in Bloomberg and outside of Bloomberg to be working on this nearly full-time for over the past 3.5 years in order to take this major vision and turn it into a reality. And so, you might be wondering, well, why would a company such as Bloomberg, decide to invest these kinds of resources, to deliver this, to put so much resources and effort into this open source project? So, like I was saying earlier, really, if you are perhaps a company weighing that decision right now, weighing the decision about whether you should adopt an open source project even though it may not have all of the features that you need at the moment, should you adopt it? Should you start contributing to it? Well, I really want to emphasize that it's important to, or at least at Bloomberg, our experience was that it's important to think, what is the long-term success of adopting this technology in my company? Because ultimately, the stronger an open source community is, the stronger an open source project is, then also the stronger, or the more likely it is that this technology will have been the right one to bet on for many years to come. And also, for any open source project, there's no guarantee that there will be continued funding for an open source project for many years into the future. And OpenSSL is a great example of a situation where, perhaps people took for granted the fact that there would be continued dedicated developers working on an open source project. So from a company's perspective, if you really want to guarantee that there is a long-term strategic success for adopting this technology, really it makes a lot of sense to also pay back to the community, because by contributing things like the widgets, bringing the widgets infrastructure to production readiness, contributing to the widgets ecosystem, or contributing Jupyter Lab to the community in collaboration with other developers here, really this all works to make the community stronger, because these are systems that are, again, highly customizable, highly extensible. They work for lots of different end users, and so they will only serve to really drive the adoption of Project Jupyter among a wider and wider audience as time goes by, and that will really help strengthen the community. So that's some of the considerations really that went into this experience. And so as I was alluding to earlier, really, you want to be thinking about the long-term strategic success of adopting this technology in your company, and also perhaps, if you think about the Jupyter community's perspective, some of the benefits of collaboration are perhaps slightly more evident on that side of the table. This includes things like, being close to your end user, knowing what kinds of features to be developing that would be heavily adopted by your end users, or having extra impetus to design very flexible, customizable systems that can be used widely, across many different organizations. Also, perhaps being able to tap into expertise that an industry partner might be able to bring in some instances, and sort of more evidently, the ability to tap into dedicated developer time or funding for the project. So if that has been slightly persuasive about why you might want to start thinking about, potentially engaging more actively in the community if you are an industry representative who's thinking about adopting this technology at your company, well, what are some tips for how to go about doing that successfully? So we asked the developers, the Jupyter, the Project Jupyter contributors at Bloomberg about their experiences, and we also asked Brian and Fernando, the leaders of Project Jupyter, for some of their reflections. And really, one of the key themes that came up was this notion of building trust, right? Because, you have two communities that, may start out with differing priorities or interests or timelines, and really, in order to come together and work together, there has to be a give and take between those priorities and timelines, and especially from a company's perspective, looking to contribute to an open source project and perhaps develop features that your company needs. It's really important to not only be concerned with just your immediate needs and your immediate priorities, because it's important to build the trust of other contributors within the community, and to build capital for yourself by sort of engaging with the code base more widely and not just the things you're interested in, and engaging with the community more widely and being committed to the entire project and not just what you need yourself. And to paraphrase Brian and Fernando, if you are looking to if you're entering a house, you know, to share that house with other people, think about first fixing the plumbing and not, you know, jumping in and wanting to tell everybody that you want to renovate the kitchen. So really, you know, it's important that, you know, there's a level of commitment shown, you know, that contributors, you know, fix bugs, fix outstanding issues, and that's sort of a way to also build capital for yourself to show the quality of your work and build a trusting relationship between two communities. So, you know, if you're interested in getting started in contributing to Project Jupiter, definitely, you know, there are lots of issues listed on GitHub. You know, participate in the mailing list, participate in the Gitter chat, and like I was saying earlier, you know, go in there, fix outstanding issues, prove the quality of your work, and build capital for yourself as a contributor. So that's really, in a nutshell, some of the reflections on the experience of this collaboration between Jupiter and Project Jupiter and Bloomberg. So hopefully a couple takeaways you might have would be, you know, you've gained some insight into the widgets ecosystem as well as Jupyter Lab, although there were more dedicated talks on those two projects as well. And if you are looking to start thinking about, you know, contributing to an open source project, you know, I think there are lots of developers in the audience here who would be happy to chat about that. One more thing that I might have forgotten to mention earlier is that often in a collaboration, you know, what is often very important is buy-in and commitment, not just from individual developers, but from management within your firm as well, so that they are basically backing up the amount of time that you are spending contributing to an open source project that may not see, you know, your priorities or your needs met immediately. So, yep, so that's in a nutshell all we have for you today. So again, thank you very much for being here at the last slot of the day. And only a few more minutes stands between you and reception. So thank you again.